Duh. Hello, hello, hello. Is there anybody there? Oh, I need to turn on bark. Bark, 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 bark. Nice. Hello, everyone. I don't know how many of you have been there, what, 2 days ago? When we're working on some of the stuff. We had a bug, a very interesting bug that was kind of a silent fail between Sema and Kojan. And I still have no idea why. Let's not go there yet. But since then, actually, some of the stuff we did for structures has already been pushed, and it works. Padding was missing though, interestingly, so had to add that and fix that. But yeah, so far so good. So today, the plan for today is actually continue the work. Several contributors have been pushing contributions to x64 codegen. And first things first, I want to have a look at this, tweak it a bit. So pull it locally, do a couple of tweaks, merge it, enable tests, because the thing was the tests, you couldn't actually test. So, right, let's back up. Maybe that's gonna be easier to explain. The contribution is actually implementing storing values to memory. It was impossible to test it because ELF linker wasn't advanced enough, so we actually weren't introducing a writable segment. So I fixed that yesterday, so we actually have read-only, read-execute, and writable segments now created. Already tested the stuff with ARM backend. So the idea here today is to merge this first, have a look what it looks like, make a couple of tweaks, because I know that stylistically it doesn't really agree with the rest of the Kojan code base. So fix this, have a look if anything for Pi is missing. Well, by Pi I actually mean macOS mainly. Hopefully in the future we're gonna have more Pi targets, but for now it's only macOS. So we're gonna start there, enable behavior test for x86-64, and continue with some other stuff. I don't know, maybe do some dwarf. I kind of like dwarf format. Right, let's do that. And pool, what do we have here? Oh, yes. Excellent. So let's have a look. Right, what were the changes? Let's that's crap, isn't it? No, no, no. And there we go. Oh. Oh. Hi, CryptoCode. That is sick. Say hi to the Tiger Beetle folks from me. Yeah, you know, I'm happy for them to raid me as well, depending on when they're gonna finish. Right, let's see. So I think it's that one actually. That's probably more than this only. Right. What? No, that doesn't look right. Right. Just a sec. Let's see. So what happened here? Okay, that's for storing. So if that stuff was not there. Right. Okay. Yeah. So storing ABI size. That's an immediate one. 2 and 4 bytes was done. 8 is the new addition. Okay, right. Yeah, so one of the things is, like, if anybody wants to contribute to x64 or any other backend, that's absolutely fine. However, right now it's a weird moment because I'm in the middle of rolling out Yahim's freeze and unfreeze registers API for Regalog. This obviously is missing here. Although, do we need to freeze? And yeah, we do need to freeze because we have reg. We don't want to, like, you know, it could happen. I'm not saying it would, but it could happen that we're actually going to spill reg and reallocate it as a temp reg, which is just nonsense. So we gotta freeze it. In fact, I think in that case we can just go. Right, what was the API again? Freeze, right, yeah, okay. It's a void, sweet. And we want, what do we want? Reg, we don't want to actually ever clobber it here in the scope. Unfreeze registers, and we're just gonna free it when we're out. Okay. Is there any potential for a recursive call here, I wonder? I don't think there should be, right? Just in case, let's have a look. Yeah, I wonder what happened then. I wonder if it's gonna assert. Like if I call freeze registers like in recursively in another function frame. I wonder what's gonna happen then. Anyway, right, okay, so this is frozen, this is cool. We can potentially, oh no wait, this is the ABI for value type. And value type is the one that we store. Right, okay. We have pointer type and value type, that's fine. So wait, we actually can get rid of this and move it here because it's probably gonna be useful. Let's keep it there. And check it out, we have a redeclaration, so we have actually declared it in a different scope too, which is just nonsensical here, yeah. Is it the same though? Oh, go away. I think so. Yep, okay, sweet. Oh, and here as well, nice. Well, that's bad. Oh, that's the new code, right, okay, gotcha. So this is another bit that we have to potentially work on. Okay, cool. So is there... Right, so to do optimization, if the immediate is only using the lower 4 bytes and can be sign extended, we can use a normal move with indirect addressing. Right. So I'll leave it as it is. It's fine. We can actually optimize that out later on. Stop. Hey, so you're is it Miguel? Is it cool? Yeah. So excellent. Actually, that's perfect. So I'm just going through some of the things that I think should be done in a slightly different way. It's not saying that your PR is wrong or anything. It's actually perfect, and I really appreciate that. Great timing, yeah. Just a few things so that you're listening that might be useful. We're actually moving to this thing. So basically, whenever you want to copy to a temporary register or even allocate a new one, we don't use exceptions. We actually freeze unfreeze. So this is the new API that Joachim introduced here. So basically, whenever you want to keep some register allocated and well, basically, untouched within a scope, we just freeze it and then unfreeze it with a defer. Yeah, hopefully that makes sense. So because we allocate a new temporary register here for the value, and we actually have the destination, I think, is a register, we need to be extra careful that we actually don't spill it, and that happened in the past, which is a nasty thing to debug. But other than that, it's cool. Right, so let's keep looking. Yeah, this is fine. The 64 here, I think. Oh, this is actually right. Okay, yeah. So temporary register has to be a 64 because it's 64-bit addressing. And ABI size is actually 8, so we can have to 64. Yeah, cool. The other thing is that we also have this thing. It's actually, it doesn't really bring much here, but just for the future, you could actually do that. Right, I don't know if you've used it before, but basically register alias says that for whatever the ABI size is, it's gonna pick the correct register size for you. And what was the 01? I think that was the reference, whatever is in register 2, right? Oh, the opposite way, is it? Whoops, my bad. I think. No, that's the destination, wait. Yeah, I mean, unless if you know that you need 64 bits, yeah, so the full width for a register, just go for it, right? Like here. I think here, having like this is absolutely fine, because we know this because we switch on 8. So that's perfectly valid. I'm just showing that, and it's actually defined like, oh, like here. There we go, right? Because here we don't know what the source reg is actually. I mean, it can be anything, right? Depending on the ABI size of the value, it can be, I don't know, 1, 2, 4, 8, whatever. So, but yeah, in general, because we know here that it's 8 bytes, 264 is perfect. I mean, if it isn't, then something is going horribly wrong, but it shouldn't be the case. Okay, right, so this is cool. I like that. Now, right, yeah, so but this is only true for non-pies, right? This for position-independent code, this is not true, and we need to actually, I don't want to do a vertical split, I want to do a split. Do we have like a pie thing here? Wait, where was this? Genset? Memory, yes, there we go. Right. We need to actually leave this for now. So this is not gonna, obviously, so your PR is great, but it's not gonna work on the macOS, especially on the ARM64. And actually on x86-64, because that's what we're doing. Also not because we are assuming pi for every macOS target. So, so we need to, I'll fix it. It's not a problem. I can add a pi thing. implement, is it storing? In fact, yeah, I'll need to. So on the topic of pi, actually, because that might be of interest to everybody here. Wait, was it pi? So basically, the funny thing is, I think I'm repurposing stuff here. Oh no, I just have, okay. It's got entry, but some of the stuff I actually need to clean up. No, it's okay. I mean, for you know, I'm on Linux. I'm focusing on Linux right now, so no props. I don't know if you saw it, Miguel, but yesterday I pushed changes to ELF linker. So your and the reason I'm merging your PR like separately like this instead of clicking a button is because first of all, like some of the tweaks, like the freezing of registers, but that's a minor thing. The bigger one is actually I want to enable the tests too, because they should pass and they should run and pass now. We are actually able to write into memory targeting Linux and ELF, because I've added the data section. It's I'm actually going to be doing more pushes to ELF linker over the coming like days and weeks. I might actually stream that too. And it's actually fairly, it's not that difficult since I wrote a linker for ELF already. Like it's not fully complete, it doesn't have the dynamic loader, like it doesn't have dynamic linking done, but static linking is more or less done for C and Zig. I didn't do the static. Yeah, cool. I didn't see the, I didn't do the linking C++ yet, or Rust or anything like this. Right, back to the thing. So, no, star. Right, I got star. That was cool. Right. Hey, Loris, how's it going? Right, do we need to save anything here? I don't think so. Because that's for memory, that's another prong, right? So we actually don't have a register lying around or anything like this. So the pointer MC value is actually memory, which is perfect. Right, okay, cool. Yeah, so in this case, that's cool. Nice. And then we switch on the value itself. Nice. Ah, right. And then we have, oh, right. Okay, wait. Value can be a register. Okay, so the value is the input, right? Ah, right. Okay, yeah. So we have to be a little bit more careful here. Yeah, we'll need to basically say that if value is, there is a thing. I need to work out some nice helpers for this. Then we do, because this is kind of verbose. I mean, it's okay, but I think we can make it like a little bit more pleasant to use. Registers, then value register, and then defer if value is register. And I think, yes, I believe so. Hi PTKG. Yes, I believe it's, I think it's GraphBox. Let's have a look. Oh wait, where do I have it configured? Shit. Yeah, because this is NextOS. Where do I have it? Let me remember. Wait, I think spam. Yes. Yeah. It is. Yep. So that's yeah, no props. Yeah, so that's an excellent question. Right. So for release builds, but this is like the future, right? We won't even go there yet. For release builds or anything that actually does caching mode, like basically whole. Let me show you. It's not this one. Cache mode, right? We have two modes for caching. This is one of the hints. One is incremental, one is whole. Whole is basically, I think is the closest approximation we have to traditional linking, and incremental is basically what Zig will normally use in debug builds. So this is, doing the in-place binary patching and hot code reloading and things like this. For debug builds, we always use incremental, and because we always use incremental, we use GOT extensively for basically any link to another symbol within the binary. So yes, for debug builds, it will always go through the GOT. For release builds, I haven't really thought about this yet. I think for release builds, we're gonna reuse the concept of basically hand most of this stuff to the linker. We might actually, I don't know, maybe we're gonna have one entry point for this, basically having a relocation saying that I want to go through GOT for that indirection, and then if the linker is able to optimize stuff out because it's the release build and we actually care about the performance, runtime performance a lot more and small binary size, it will take a note that yes, I have the definition in another translation unit or actually is available right now. I'll just optimize this out. Like I will relax the GOT relocation. But for the debug builds, yes, we are going via the GOT exclusively, pretty much. We don't optimize that out unless things are within a translation unit itself. So you can imagine a situation where we have the Zig module and then we actually link object files that were created by compiling C. Like I did a couple of those demos for macOS. By the way, Maco linker is slightly more advanced for this stuff because it can actually link object files. Where we had like Zig module and then the object file, and then anything within the object file would have all the link time optimizations applied, like relaxations for things that were defined within the object file, and anything else in the Zig anything else would really go via GOT. So yeah, that's the general idea, I guess. Sweet payload destination also is 0. Yeah, I really need to like create a new tag for this because this is really wasteful. But one thing at a time, I guess. Cool. Okay, right. The only thing I'm kind of skeptical about here is this. I think I'd like it separated out. Basically have like flags. Something like and then we can just switch on it. It's just for readability, to be honest. I think it's easier to grok. And then the flags. Do it. Oh, so in fact, we don't need this. Do it this way. And then if flags, just handle this case. And oh, actually, and in the beginning, immediately, because we don't need to do this stuff, if ABI size is larger than 8, we just do your fail. Yeah, a little bit. I agree. Yeah, I think it's easier to just have it. I mean, you know, things. I'm pretty sure things will get reshuffled over and over because this is kind of young code base, right? So, but it's great though. I like the checks. It's very useful to have those. And right, do we actually use the top bits anywhere? Don't think so, right? Oh Jesus, not that. Oh, because you just do a check, right? Cool. Yeah, and if it can extend. Yep. Okay, I think that's awesome. And then if it can, then we just on here, just do that. And I think it's slightly more readable. I know we have more prongs and switches and all this stuff, but I think it's slightly more readable. And if ABI size is larger than 8, we don't handle it yet, so we just return with a failure immediately, which is perfect. And then we have a switch. We don't have anything else. So we don't have to do like an early return here at all. Okay, nice. And then if it's a red, okay, so for red, we already frozen it. Nice. So nothing to do here. Perfect. I think it's awesome. Right, so right, which one was it? I think it was 1486. Yeah, so this should work. Oh, and by the way, I changed this test a little bit. It was U64 here, but I changed it to usize because ARM doesn't implement U64 yet, and it's a 32-bit target, so I think it should be fine having usize, to be honest. I don't think it was testing like anything by having U64 here. Okay, let's try and build it. Oh yeah. That's a hard error. Cool. Well, a fatal error, I guess, a trap. How did the stream go, Loris, by the way? I didn't watch to the very end. I mean, I think I had it turned on, but I had to go and check on my daughter. But how's the autodocs? Like, did you find a way to deal with types and stuff in ZIR? Or kinds? I think you call them kinds, not types. Cool. And we can immediately try that one. Let's just change that to usize. That's data. Okay, so far so good. Yay, it works. Great job, Miguel. Thank you very much. So now let's try. Oh shit. Let's try the tests. Yeah, I have a massive thing like Andrew now for testing all the targets. Boom, works. Perfect, sweet. Right, 1486. See that? Don't need the built-in anymore. Or maybe I should leave it. No, maybe not. Because the ARM64 is coming soon. I think Joachim's making some really good progress on this. So we should have Zig test passing soon. And then Loris is going to be very happy because he'll be able to test stuff on his M1. What the hell? Wait, what? Wait, this is for, what is this for? Implement more pointer equal class cases. Okay, what the fuck? That's amazing. Was this one of those Heisenbergs? Nice. Is that? Is that because I touched it? Like, if I bring it back, is it gonna? Nope. That's not cool. I wonder what that is. Okay, cool. Oh, and run the tests too. I don't wanna. Come on, work, please work, please work. If it works, we're just gonna merge, like commit, merge, push, and we're good. Yeah, those are not exactly luxury tent. Those are the types of bugs you'll sleep over. Yup. Of a cosmic ray incident. Did I? Oh, Loris, I delete my cache every day. A couple of times a day. Like after you and Andrew pointed out that if you make any tweaks to ZIR and stuff, ASTgen, you gotta nuke your cache. I'm very careful to always do this after every meal. Yeah, exactly. You know, having sip my coffee and then nuke it. Yes, it is. Is there anything I could do to actually maybe make it quieter? I don't know. I mean, it's a cool machine, but the graphics card is pretty weak because it's the AMD Noir, so and then I can potentially like maybe reduce the sensitivity. Wait, let's have a look. You can check. Wait. Filters, okay. Noise, wait. Noise removal filter. I have compressor, expander, gain, invert polarity. Is that noise gate or noise suppression? I guess it's a noise suppression, is it? Or gate? Suppression, right, yeah. So I thought, okay. Okay. Okay, is it any better? I think so. I think it's actually removing the, it's matching. Big improvement. Okay, cool. Sorry about this. Okay, cool. So let's have a look again. Nice. Unpack for later. Unpack this a little bit. Enable the test. Awesome. Oh, if anybody's going to be running the Zig test on x86 for macOS, you might get a to-do for that test case because of the Pi stuff. But we'll get there. So where are we? Let's do to do for pi. Right, what was next? So I can never remember the manual for this. I've done that. Check out master. Okay, and then I think just push, yeah. Sweet, and I think this should close the merge. Yeah, nice. Excellent. This is looking really great. Okay. Right. So we got this. We are on master. Oh, the CLI stuff. No, I don't have that stuff. I just get regular Git. Thanks though. I might when I'm gonna be doing more work on Windows, I might actually use that. I think that's the recommended approach. Cool. Right. Okay. So one of the things that I want to do, copy to new register. Okay, this is gonna be kind of tricky. But so for example, this we don't want this at all. We can get rid of this right now. So we don't want any exceptions whatsoever. Copy to new exceptions. Yeah, no, anytime, Miguel, anytime, and please keep them coming. Andrew, this up. Yeah, I think I share. Loris, I think I share Andrew's view. I also, I don't, I like bare tools, no magic, or as or minimal magic. Right. Okay. So let's have a look. What do I need to freeze here? Okay, if both of them are memory, then that's okay. Right, okay, so I think in this case, so let's have a look. Right, so if RHS is register manager freeze, and then we're going to freeze, right? And then defer restoring it, and then destination MCP can actually only be self copy to new register, I believe. Wow, this is pretty clean. Oh, good. As register, right? Let's register. This is this time left-hand side of the operation. Freeze registers. And then we defer. Unfreeze. Are you? Oh, hi, the real Mitchell. Are you asking me or people in the chat or everybody, or is that like an open question? So for me, actually, My first contribution was actually getting WASI up to speed in the standard library. So prior to this, I was collaborating a lot with Bytecode Alliance people and Mozilla people on WASM time runtime for WebAssembly and WASI. That was in Rust, and then um, I saw Zig somewhere. I was like, okay, cool, interesting language. I saw it. I was like, yeah, okay, maybe this is something like C or like a better C or something, whereas Rust is a better C++. So I contributed this stuff, and the first thing that struck me was that there's no global allocator. I was like, what? How am I supposed to make it work? Like every single language that uses WASM and WASI expects a global global state. How the heck am I supposed to do this if I don't have a global allocator anywhere? Like what? So but in the end came up with this cool thing, and I think this is really, really clear. Wait, let me find this for you. Yeah, we have WASI uses this concept of pre-opens. So basically, these are like capabilities, some capability-based systems, kind of like Capsicum, I think it used to be, whatever. So basically, you pass a capability, and but when you launch the process application, and then if you have it, then the app is actually allowed to, I don't know, open a file within a directory that's a capability and things like this. So all of this stuff, the pre-opens, which currently are only like descriptors, so that these are file descriptors on the host. On every, like in C and Rust and C++, they expect a global allocator, and they're in C, in WASI libc, I believe they are part of the init routine, basically. So that's when I think when you compile using WASI libc, the static, like the initializer is run first, so it actually sets the global allocator for you. Well, it's already there, I guess, but it does the pre-opens for you. It asks the runtime to give you back the pre-opens to the app, what I'm allowed to see, what I'm allowed to open. Whereas in Zig, we took the approach that if you want the pre-opens and you wrote an app, you want them, you need to ask for them. So you are able to defer all this until after you enter, and you're giving back the control. The app is getting back the control, and then you are in full control over if you want to get the pre-opens, when you want to get them, how you want to allocate them, things like this. And that was cool. I was like, wow, this is awesome. A little bit awkward at first. I think people coming from different languages may find this a little bit awkward, that this code is happening. Like you have to invoke the code to get the pre-opens. But that's why Zig is a systems programming language, like a lower level than Rust, I would even say, and it's cool. So this is when I first started. That was almost 2 years ago, and yeah, I had so much fun that I talked to Andrew and Loris, and I'm working full time on it. So good fun. Oh, and the learning opportunities are like insane working on Zig. There's so much cool stuff that you can do and learn. It's mind-blowing. Right, okay, this instruction, that's okay. Right, where are we? Register, self-copy to temper, register. Yeah. So this is interesting. Like I never actually used Go much. I just tried it very briefly for like, I don't know, a couple of days. But I hear it's also like it's a simple language, much like Zig. Zig tries to be simple. It's not like Rust where the type system is pretty scary. It's very powerful, but it's pretty scary. So yeah, Zig. I think Zig should be a lot of fun for you. Right. So we are copying to temporary register. Do we need to preserve anything? I think we do. Yeah, Zig definitely is lower than Go, right? We don't have anything like a garbage collector or anything like this. Like the memory's up, like management is up to you. Yeah, no props. If you have any more questions, just feel free to ask, like either me or anybody in the chat, like Boris or other viewers will definitely be happy to answer your questions, and so will I. So, yeah, crypto code. That's I don't know, to be honest. I need to have a look. Let's have a look. So it does an error. Yeah, I think basically if get register mask. Wait, we have alloc index. Oh, this is dependent on the architecture, isn't it? Is it? Alloc index, yes. Right. So we return some index. We have a shift mask, is it? Oh no, it's how many bits we want to shift. Okay, right, because we actually have it compressed. Then we create the mask. Yeah, I think it looks like basically it doesn't error out. Basically, if something is already frozen and you don't unfreeze it, it stays frozen. So yeah, I guess my worry about calling freeze registers in is there a potential back source? Yes, but not in the sense that it's. So what this kind of thing lead to is that if we freeze too many registers and we forget to unfreeze them, it's kind of like a leak, right? So, we're gonna run out of registers, and at some point we're just either gonna generate some bollocks in terms of the machine code, or we're gonna basically crash because we won't have any registers and we need them potentially. Because then alloc reg is gonna fail. Like this code can fail. If we cannot allocate, it will fail, right? So basically the error will still be flagged, will still get flagged up, but it will be kind of deferred. Like it won't be flagged up in where we freeze it. It will be flagged up when we want to actually allocate the register. So yes, I guess it can lead to a nasty bug that you can't find it. Basically, it crashes. You don't know why. But it's kind of like a leak, right? So we potentially can add some like a wrapper or higher level management, kind of like we have the testing allocator or GPA in general that is tracking freeze and leaks and stuff. So we can definitely have this in debug mode and basically, for the development of the compiler. And if anything was not unfrozen or we forgot about this, we can just count that and then flag up that, yeah, you forgot about this here. And I think it should be fine. I mean, I haven't, I'm still playing with this API. I haven't really, as you can see, I haven't even ported most of the stuff yet, so. Right, so if, right, let's do it this way so you can see what the heck is happening here. Can we do this now? I think so. I'll try. Right, so we potentially have. So okay, so source MCV is definitely not registered because we switch on it and it's immediate. It's fine. right? But the destination MCV, if it is a register, and can it be? Yes, it can. So I think we should check here. This is the only thing I don't like. The fact that it doesn't play nice with MCV in the sense that I have to constantly check if it's a register. I'd prefer to basically just, leave an empty statement, just freeze it if it is a register. Actually, maybe it's actually not that bad. Maybe we could do this here, right? Because we already did that stuff here, and then we could have something like I don't know, thinking of something like that. And then having something like and then within here, we'd actually do the exact same thing that we did there. If is register, yeah, if it's register, then we basically, oh, I still, right. Does this, what does it require? Hello. So you made it look. Ah, before 3 p.m. Nice. And then manager freeze registers. Nice. Welcome. Then MCV. Oh, actually, you know what? We can actually unpack it. I don't know. Would that make sense? And then register. Unfreeze. And obviously, like that. And then, yeah, and I think in this case, this then becomes, what does it become? Destination MCV freeze of register. And then defer destination freeze. I don't know, what do you think? Is that any clearer? Like this. Why is it complaining about something? Okay, I'm confused. Why is it complaining at me here? Yes. Did I eat something out here? Or is that, no. That's weird. Why is that not? So wait, the register manager is not a type. It is a type. Why is it complaining then? Found. What? Oh, right. Of course. Um, let's do a trick. Let's do a tiny trick. And then this should be fine now. Yay. Yeah, so what do you think? I think this is slightly cleaner than having if statements, I think. So here we would do freeze the register. Some tracking basically. Look, yeah. Yeah, I think this is a good idea. Yeah, it worked. Cool. So yeah, and this might be very interesting for you, Miguel, in this particular test, this particular function, which is wait, this one is one sec. Oh, so this is generating binary math operations. I think we have what add, subtract, XOR, OR, and AND. We had a nasty problem with spelling, or if that was called multiple times, we would actually there could be a case that we would we wanted to allocate the new register, and turns out that this register was one of the operands here, and we would spill it, ending up with basically trying to do an operation on, on, instead of being A and B, we would just do AA. So it was a nasty problem to spot, to be honest. Okay, I think this is this looks slightly better. I mean, to my eyes at least. I don't know. If it doesn't, then I'll go back to the if statements. But I think this is slightly less verbose, but at the same time it's still readable. We don't need the if statements here. So I think it's fine. Let's try again. Yeah, look, so you missed the fact that actually we can, thanks to Miguel's contributions, we can now write to memory with x64. Hey. Yeah, it's pretty good. I need to add more stuff to ELF. Like, we don't have any zero fill. And zero fill is actually very interesting section. I have no idea how to track that incrementally yet. So, and by the way, I don't really do any tracking of BSS section or thread BSS in Mako either. for incremental linking, I actually treat it as a normal section, which means that the size of the binary blows up the moment you have an array of like, I don't know, like 2 million elements. It's actually going to be 2 megabytes of a binary, because everything is going to be zero filled, which is just ridiculous. But hey. Nice. Okay, so let's see, freeze. What else? Yeah, see here again. Operand, freeze of register. Oh, you don't have to omit the BSS unless you import memory from the runtime. You import memory from the runtime. What does that mean? Is that one of those calls to grow memory or something? Hey Yahim, how's it going? Oh, Yahim, you might be interested in this. I don't know whether you're gonna like this idea. I kind of created like a helper function for MCV, for freezing a register like this, because I got kind of tired of doing an explicit if statement. I don't know. Let me know what you think about this. It's basically wrapping the if within a helper in MCV. So anyway, look, so wait, so what does it mean to import memory from the runtime? This isn't to do with growing memory, is it? No, because this is given to the guest as is, right? So, oh, is this for like exchanging memory, basically that the host can pass you a pointer or something? Right. Right. Okay. So yeah. So basically, the runtime is giving the guest a pointer, right? And then you need to be able to somehow access it. So why do you need VSS for this? So you write the wait. Why do you need the zero fill for it? I thought the data section would be enough. No. Oh, okay. And it's initialized later. Of course, it's runtime, right? So it's not going to be initialized until it's loaded. Okay, makes sense, right? Got it. Yeah, sure. Oh, actually, I wonder if you could. So if you could do an experiment, because for example, currently, at least in ELF, because I haven't I did the bare minimum to get the data section working. But yeah, you can see here that basically if the value is undef deep, so it's actually poison here. I don't even I'm like whatever. I didn't even try and create BSS. I just return the index of the segment that contains the data section. Oh, by the way, with incremental, at least that's the current, I think, design for ELF linker. I'll need to see if it will be doable or not. There is a one-to-one mapping between the segment and the section. So we create a program header for the segment that's read and write, and then we have one section in it. In this case, will be the data section, and this is because we want to have freedom to move it in file as we please. And if we had segments with multiple sections, kind of becomes slightly more complicated. Like this is the case with Mako. With Mako, like I don't do it this way, mainly because it's a pie. So being able to move it free like this, I don't know. I mean, I wanted to do it like that, but it wasn't. I don't think it was beneficial enough, or maybe I didn't see it yet. We'll see how it behaves, how it fares with bigger programs. But basically, what I do when I grow a segment or a section, I only have 3 segments. I don't have a segment, one section per segment. I have segments with multiple sections. And I just basically, if something needs to grow, I just extend them. I actually hook if a section has to move, it pushes everything downwards. So I do a copy of the memory, but because everything is based on relocations anyway, updating the references within each section or symbol or atom is done automatically. So that's how it works in Mako. In ELF, it's not like that yet. We actually don't handle any relocations just yet. So, but anyway, right, okay. Yeah, I mean, BSS sections are always zero filled in any target, I believe. It's not only WASM, right? In ELF, in Mako, but they are like, you know, the trick about those, and I only I only understood it recently, which silly me. Zero fills don't require physical presence in the file. If there is some space between the start of the BSS and the next section, the next segment, then you have to zero fill that bit, but then the rest is actually created on the fly by the loader. Someone made an issue about this, about the BSS stuff. Huh. But so wait, they don't understand what, like how zero fill works. Oh, okay. In that case, I know that this isn't WASM, but if you bear with me, there is and I had no idea how to show it, explain either. Wait, let's look. There is this fancy, I think it's a utility tool written by Google. It's called bloaty bloatface, whatever. It basically analyzes Mako binaries, and you can see that. So this is before the change that I made, and this is where I was actually filling in the zeros myself. Zero fill BSS was actually physically present in the binary, and it's visible, like array here is undefined, right? And I think we were actually yeah, it's undefined. It's going to get placed in BSS, and it requires like 2 megabytes, roughly. I think 2 million. Is it 2 million? Yeah. So 2 megabytes, right? And if you look, in virtual memory, obviously is going to take 1.91 megabytes or whatever, or maybe bytes, whatever that is. But it was also taking the same amount in the file, because I was actually creating the entire thing myself, and I was actually filling it with zeros myself. So technically, the loading should be faster because the loader doesn't have to do it. But I think the difference is minimal, and the size just explodes. There's no point in doing this. And then after Andrew pointed this out, that actually no, I'm wrong. This should be zero filled by the loader, the OS, not by me. You know, we only store the bare minimum, and the bare minimum corresponds to the difference between the start of BSS and the next segment, in which case the link edit. Because in Mako, I think it's in every file format, BSS should be the last section within the writable segment, so that you can basically just, it ideally would be size 0. So if you want to explain to someone, just basically, you know, you can point to that PR with this example or some of the issues that we have for Mako, and it shows exactly why and how it works. I can also do some screenshots for you if you want, showing how it actually, what's the difference in file size to, oh, even Andrew explained to them, yeah. Well, you know, sometimes it's difficult. It you know, yeah. Right, this is cool. Okay, let's keep doing this. Oh, nice. And value, freeze if register, register manager, and then we're gonna defer unfreeze. And this is cool, this is cool. Again, this is Okay, nice. We can actually do a quick test, see if it works. And then we can have a look at more stuff. I think most of the stuff will be in alog reg. Yeah, see, here, for example, we have exceptions that we need to get rid of. Oh, and by the way, I don't know if Miguel is here still. If you see that some instruction, like an MIR representing an instruction is missing, or you would like to add something, feel free to propose it. So that would be in, wait, in the x86-64 MIR. You know, there is actually some of those are still unimplemented. I can't actually remember what it was, but feel free to basically like suggest something if you need something else. This will also get I think I'm gonna clean up in the future somehow because there is some of the stuff that I think can be separated into separate tags because you know we can have as many tags as we want. And there's no point like squeezing everything in unless it makes sense. So, but if anything is missing, then yeah, like for example, scaling for move apps, I don't think I've added it. I did implement a lot of the encoding though. Obviously there's no like, you know, no SIMD or anything like this or FAT support, but there is a fair bit of encoding actually implemented now, which is pretty good. And I'm actually following the official AMD and Intel spec when it comes to naming convention as well. So, yeah, things are here. Anyhow, let's get back to it. Okay, this passed. Let's see the tests. Want all of them. Nice. Okay, so this is good. Mm-hmm. Gonna be a working title here. Oh, okay. Are you I wonder, are you Joachim on is it a broadband that you're on, or um, is it like a mobile modem or something? My parents got a mobile modem at home and it's horrible. And I spend some time there in the summer when I'm staying with my daughter, and it's yeah, like no streams then. It's absolutely atrocious, like nothing works. Right. Okay, so we'll do it this way. Okie doke. Right in here. So we've got to. Okay, sweet. So here, oh wow. Like a value being split between two registers. I see. Yeah, so this would be, yeah, okay, so, I suggest though that we, yeah, so basically, I'm happy with adding anything new, provided we have test coverage immediately for it. Yeah, sure. Okay. Yes, I'm yeah, definitely looking forward to that. That'll be very useful. Returning struct via registers, yeah. I need to have a look though, if we have all the necessary lowering code done for the type though. Need to have a look at that. So because we're missing some of the, we don't actually lower all the bytes that are required yet. We don't encode all the types that to do, and you know, but basically, I wanna, if we wanna add like a new MC value for that, that's cool. But when we do that, I wanna have a test for it immediately. Because otherwise, we just add it and forget about this, then we do it, and we have to redo it from scratch. And just, I don't think it just makes a lot of sense this way. Right. Okay. So temp register. Wait, can we just copy it over? 434. I don't know. Why is it boring? It's like maybe my stream is boring. Maybe the coding, in my opinion, coding is not boring at all. What's the difference between coding and programming? Oh, okay. So yeah, I'm not sure I can answer it because for me it's not boring. Programming or coding. Really? Yeah, I don't know. I think I'm in the camp that actually says like I really enjoy it. It actually calms me down. If I'm stressed, I can just code and it's cool. Oh no, Joachim. I was actually looking forward to it. Maybe tomorrow then? When you start building stuff and seeing a result, well, yeah, for sure. If something works, and the more difficult the problem, and you see it working, as the better, right? So this switch set reg that's not gonna work. Okay, cool. So okay, so this looks fine. We've got it frozen there, so we don't need exception. Then here we need again register. Oh, that's it. 240p in really big font. Oh my god. Why do I need 3 languages to build a site? Actually, you don't. You can do everything in well, okay, you can't. That's true. You can't do everything in HTML, but you can definitely build a site in HTML only. So yeah, but so you're talking about, I guess, web programming, right? Web development. I don't know. Maybe doing something. Uh, maybe you could do something a bit more lower level. Maybe that would be more interesting to you. You could actually use, just solve everything in one language potentially. I don't know. Try Zig. Unfreeze registers. I see. Right, register is already frozen. That's cool. Oh, okay. See you then, Joachim. Have a good one. Get register. Okay, this should not trip or trap. We can clean this up. Yeah, where's the count register? Okay, it's been allocated. Do we need to like? Oops, what is happening here? Do we allocate? No. Okay. Mem copy. Oh, and here as well, right? Okay. Wait, this is stack offset. We have a register lying around. No, we don't. So we should be fine here with no exceptions. But here, freeze registers. Unfreeze. Okay, cool. I might just do that one and then basically take a break from this and then we can look at something more interesting perhaps. I don't know, maybe some dwarf or something. I really started fancying dwarf, like this is a lot of fun. You know, adding more abbreviation for types and stuff. Pretty cool. Especially seeing that work in the debugger, it's like, yay. I know you are, look. Just one sec, let me finish this though so that I don't forget what I was. Oh, is there another one? Inline mem copy? Yes, there was. Oh, for sure, man. Like the bagging, yes, the bagging was it's gonna be amazing if it, you know, when it happens. Not if, but when. I think this is, oh, this is genset stack. Okay, stack offset, copy temporary, so that's fine here. Here we need to freeze some stuff. Register manager. Yeah, we don't, well, we have tracking source line. Actually, adding source line tracking should be pretty straightforward for you because we have MIR instructions for this. And I was thinking maybe we can actually reuse a lot of the functionality we have in Elf, because it's definitely going to be reused in Mako. So far I had it copied over, but there's no need. So maybe I'm not sure what the dwarf for WASM looks like, but I don't expect it to be right. Exactly. There might be some differences in the way you use it, but I don't think there's gonna be much. I think the format is pretty standardized, so it's gonna be, you know, regardless of what the target is. I think because I think this stuff is being set. The linker will set all the information about the target first, and then everything else should be common, I think. But I'm not an expert, so we'll see. Still learning this stuff, so okay. quick test to see I didn't mess anything up. And we can have a look at some dwarf. So what I wanted to do for dwarf, but I'm not sure how to even start doing it, was actually emitting information about locals. Because I think this is one of the things I think we're currently missing, and it would be cool. Because we have a pretty good coverage for function parameters. We don't have structures yet. I should add that. But we've got slices and some other primitives too. We don't have arrays also. I need to add that too. Okay. This is looking great. Let me just push it, and then I'm gonna finish it off later on. Because this is kind of boring work. Nothing super exciting here. Okay, let's check out master. And let's have a look. So let's have some fun first. Right. For structures. Hey, what about this? Does this work? I don't think so, does it? Wonder, what is your... Oh. Can't see that, wait. Let me just be extra sure that it works. Oh, cool. If this works, I wonder if we can have if we can pass structure as an argument. Or better yet, we can have a pointer to a structure. And then we should be able to dereference that stuff. Yeah, sure, go for it. Ask away. Don't need that. That's cool. And let's do... Don't know. Oh, we're gonna do pointer to... Yeah. By he deserves credit for that, you mean Brendan Eich, is it? He created JavaScript in 10 days. Oh, that's a difficult question. I mean, I don't know. I mean, well, he definitely deserves the credit for this, right? Because he did it. Yeah, Brendan Eich, I think. Well, yeah, it's true. I mean, the ECMA script, the ECMA standardization body made it slightly more readable, I guess. I don't actually mind JavaScript too much, to be honest. It's maybe not the best language ever, but it's okay. I don't know. What does everybody think? I don't really have a strong opinion about this. Try my pointer foo. I see. So for me, JavaScript is fine. like ECMAScript, I don't know, 6, whatever it's now, like whatever we use nowadays, the latest one. The thing that I find very difficult to get into are all the frameworks around this. Like I was working very briefly for approximately 3 months on React framework, and it was overwhelming. And I've been working professionally as a software engineer for quite a few years, and getting into React, I was like, wow. And things would not work how you would expect them to. Like, okay. Oh, I know. We're gonna do set foo a. Although we don't need that, right? We can actually, because even if we break in first, self should be by pointer. Yeah. Sure. Yeah. I guess that's the best thing to do. Just keep trying. I mean, try different languages too. You might find something cool in a different language, different. I don't know. Maybe try even a different paradigm, like a functional programming paradigm or something. It might hook. It might like make you want to program a bit more or something. Oh, this is via this how any program can talk with other program. Yeah, you'll need to be more specific. What do you mean by this? Wait, where am I going? Oh, oh, that's via we have there is a convention. Everybody is following the CABI rules. That's how basically you speak to C, basically. But obviously this is not true for other languages, for example, C++ or Rust. Like Rust doesn't have a stable ABI, meaning that in Rust between versions or even minor patches to the compiler, things can get reshuffled, and you're never guaranteed any layout. So don't do it unless you are actually. So for example, we can, if we wanted to, we could actually speak to C++, even Objective C, I believe, like without going via the C ABI route, because we bundle Clang. But this is only we would only be guaranteed to speak to those programs that we compiled. If anything was compiled by a different C++ compiler, for example, then no guarantees. And I think this actually also applies to C++ compilers themselves. So if you build something with GCC and Clang, then don't expect things to work. You mix and match. Again, not an expert here. That's what I remember from when I was writing the linker. It's like, yeah, you can expect a lot of weird stuff. Okay, cool. So if we break, let's say we break in first, why not? Yeah, okay, so we have, what do we have populate self? Okay, what is self? See, no type. No type yet. We can't do this. Oh. So how about we go and do that? That would be cool. Okay, I think we can get something working pretty fast for this actually, because I believe I've done some of the work for it already. Right, we have struct member, we have anon struct type. I think we want to have a struct type, not only anonymous. Anonymous because that's the one I was using for the slice. Slices are structs, or at least that's how we represent them. Linguistically, as structures, like anonymous structures, right? That have two fields, two members, a pointer and length, but didn't have a name. So how about we create a named structure type, maybe 6, 7. And let's go here. Okay, cool. Right, so we have, so this stuff here, let me go back up. This is basically what we write out to the debug abbreviation section for Dwarf. What this looks like, actually, if you have a look at, so by the way, if you ever want to browse what your Dwarf looks like on Linux, and by the way, Linux is great. You have all the tools that you need. It's object dump with flag, like basically -G. This will print all, basically this will parse all of the debug info that you have. If there are any errors, they will be flagged at appropriate places. So for the abbreviation section, what is it? Wait, more, blah, blah, blah. There we go. It's that one here. And then we have all the tags. So we have the meaning of each byte. So we have basically for in the abbreviation section what we specify these the tags basically, which are like kind of like an overlay over the actual bytes that we're going to be encoding into the byte section that corresponds to this abbreviation section. So for example, when we have like pointer type, we have two fields. We have add type that is going to be DW form ref 4 means 4 bytes. Fixed. I don't think, yeah, it's wait, let me remind. Yeah, so ref 4 means fixed 4 bytes as a reference to another type within this table. So we can basically because pointer type is a composite type, we don't actually pointer on its own doesn't really mean much. It wraps another type. So this ref 4 will then point like an edge within a graph to another type. For example, a base type, if you have a pointer to U8, we're going to point to wherever the definition of the U8 is within our type section for Dwarf. And so, yeah, so these are just descriptors how Dwarf or how the debugger is meant to interpret the bytes that it sees. So basically, we kind of decouple the description, like the enum tags, if you will, from the actual data. It's more or less like how we do the data-oriented design. So they're not together; they're in two different places. But then the debugger kind of overlays them on top of each other, and then can know that I expect type here because according to the descriptor here, I should see 4 bytes describing the a reference to another type within this table, and then we have a value field, which was, I actually don't remember what the value was. What was the value? What was the value? Oh, this is a sentinel. Sorry, it's basically closing the it's closing this descriptor. So for structure type, we replicate what we have below. I really should like fix the formatting here, be more readable than. We need a sentinel, not sentinel. And then we have a bread struct type. And it's going to be almost similar, almost the same, in fact, to the one below, the anonymous, but one difference. Children, yes. One difference that we will have a name. That we will have this as well. So we have children, yes, and this is this closes the header. Then we have a name because it's going to be a name struct. Then we have actually we can have byte first, so basically where it's located. Yeah, we can have the byte first. S data is I think it's leb 128 encoded. That's Luke's favorite. Everything in WASM is leb encoded. Why not? The same thing here is like, I think WASM is based on Dwarf. Everything is leb encoded. Yeah, everything here. Oh man, you're gonna love Dwarf. Everything is leb encoded pretty much. Obviously, you can be, you know, you don't have to follow suit, and then you can have some fixed things like ref4 or data4, which are fixed in width, but as data is 11 coded basically for the byte size, because we have no idea how big it's gonna be. And string is I think it's null byte delimited, I believe. Yeah. Okay. So basically, so this is it. To be honest, it works. Look, DWARF output actually works with incremental now in ELF. Not so much with Mako, but it actually works with ELF. Even like if you reshuffle stuff, for example, if you don't touch the atoms, like the decals, they're fixed. Basically, the body doesn't change. We have as many, like the compiled machine code within is fixed. We didn't change it, but we have moved them around. Like we had main first, then we had something else, but we swapped them around. We are not going to recompile, like relink anything to do with the symbols themselves. We will only update the line numbers, and it works. You'll see in a minute. Basically, it's so much fun actually. You know, you can do the what flag and do a couple of updates, and it's like boom, works. You know, line changed. Yeah, with minimal linking and compilation time. It's magic. Okay, and this is it pretty much. If you're wondering, like, what about the members? Why don't we specify them here? Members are specified dynamically. We have this thing, abref struct member. So basically, when we say that we have children, we expect any other type from the from this abbreviation section to follow. One thing to remember is that when you add children, you have to delimit. So basically, you open the structure type scope, you add the members. Each member has to be closed like a normal scope, like you would close the braces, and then you have to close the structure type with a 0 sentinel as well. And this is not visible here actually, but it's that one. That one has to go at the end too. So, but we'll get there. Okay, so this is cool. Pardon me. This actually should work. So this shouldn't. This shouldn't destroy anything within the generated dwarf output as we have it right now. Everything should work as it did. So for example, the debug info for this should still be there, because all we just added a new type that we haven't really used yet. But we did update the indices here for these ones. Oh, right, yeah, so this should be fine. What we should see now in the dwarf output for simple binary, we should see the new abbreviation type, just not used. So let me get rid of this. So if we do that and then break. Or maybe not. BFD warning has a section extending past end of file. Oh yeah, see, maybe I messed something. Unless maybe I messed something up with elf linker updates. I definitely need to work on it a bit more. Okay, cool. So this is still working. I wonder what that is. Whoops. I wonder if this is actually extending beyond. Oh, maybe I didn't update something. No, wait. Interesting. Let's have a look in the header. Did I forget to like sections? Maybe I didn't put them here. detect alloc collision, allocated size. No, I did. Okay, no, it's fine. Yeah, I have some. Need to have a look. I think there are some problem with sizes I need to work out for the sections. But anyway, I'm digressing here. Let's go back to the debug info first. So okay, we have that one here. Okay, this is where the magic happens. We have this fancy oh, actually the magic happens in two places. Maybe anybody, maybe some people are interested in this here. So some of this stuff it's happening in emit. This is the emit is the bit of code that's actually responsible for converting, like, abstracted away set of where we want the instructions to be for the given architecture into actual machine code. And the same for DWARF. We actually converted into not relocated yet bytes for DWARF that we're going to relocate in the linker code. So debug line. Oh, we have arg debug, yeah, there we go, info, and we do gen arg debug info, and we got two entry points here. Our basic MCV is either register or stack offset. I think we have more, but we don't have it implemented yet. And this is where the first bit of the magic happens. We actually, as you can see, this is for the formal parameters to the function. We have these as helpers, but we basically specify the bytes that go in, and then we leave stuff out for relocations too, which happen here at debug info type reloc, because we don't yet know everything. Yeah, see, so adds a type to the debug info of the current position. The bytes will be populated later after codegen for the symbol is done. And then that stuff is being filled in here, or in fact in it starts and finish update deco. We iterate over all the relocs that we have created, and we finish populating the types. Now the main change that I did to this function when I was working out some of the more composite types, the fact that we have to call this one recursively, much like we do for generate symbol, or basically whenever we want to lower a type to bytes, if it's a composite type, we don't actually lower it in one go. We basically just access each field, or I don't know, like a pointer and a length, and then we lower each recursively. So the same thing happens here. So we have bool, we have int, we have optional, pointer, and then we have an else that we didn't do. So let's have a look what we're missing. Let's rebuild it with the backlog link, and let's look for to-dos. There we go. To do implement debug info for type simple foo, and I believe this type is a structure. Have a look. So, oh, maybe not. Wait, this is one sec. Okay, let's have a look into the zig type tag. What can we actually get here? Int float error set. We've got a type, but I think these are comp time things. We have array, we have vector, we got optional. Oh, we got struct. Nice. So we're missing this stuff. So what's happening here? We have, in our example, we are trying to print. So we're entering. We're breaking here. Function first. And function first takes as an argument pointer to structure foo. So we do generate pointers now, as you can see here. We actually have the address properly filled in for that pointer. The problem there is that we do not, as I showed you before, we do not have any information about what the pointee is. So we need to add that in, and this is going to be the structure. So the way this code works here, we see a pointer, so we enter here. Is it a slice? It is not a slice. So then we just go here, we do the add type. We leave a relocation for it here. For the composite type, the next type down is not a basic type, it's actually a structure, but because we don't generate it, we just add the padding, which is just basically zeros. We fill in the relocation to this padding, which means it's a void type. We have no idea what's inside it. So now we're going to fix that. Add a struct, and I'm going to cheat a bit. I'm actually going to copy a lot of stuff from here. And then maybe we'll be able to abstract away some of the stuff into functions or something. Okay, this will have to obviously change because we'll have more bytes that we need. I'm just trying to think if we can actually estimate any of this stuff. I think we might not be able to completely because of the... Oh no, wait, maybe we could. Because the thing we need is basically estimate how much space we need for the field names, but we could probably do some meta programming here and actually estimate it up front and allocate enough so that we don't have to do any allocations later. I think that would work. Anyhow, okay, so we start with this. We have a structure type. We do have a byte size, but we need to pull it. Wait, do I pull anywhere ABI size? Pointer type. Base type. Yes, we do. Like that over here. Yeah, exactly. Just that we do not want it like this. So actually we do need ABI size. Type ABI size. And I'll explain why in a minute. This is because we actually do not know how big it's going to be. So we need to lab encode it. And how did we, where was the thing for lab encoding here? I think I used it before. I can never remember the actual, function for it. Right, let's do it like this first. What did I do? Oh. Okay, we'll fill it in later on. Right, okay, we start with this. Got the ABI size. I think we had lab 128. That's for the relax. I could have sworn I used it. So if it's not here, what if it's here? Yes. Okay, that's exactly what we need. So this is the bug. Info buffer. and the writer, and then we need what we want to write API size. I think we just want ULAB, right? We don't actually. I need to check what is what was S data compared to something else. Let's have a look. DW form. Oh, so it could be U data. I don't know why I have S data there. Okay, let's leave it as S data for now, because it doesn't really matter. I don't think we're gonna. Exceed the capacity. I'm not sure whether we can use a try here. I think it should be fine. Oh, don't need that. Okay, so we wrote this. We have the DW form as data for byte size, which is cool. Oh, and now we need DW at name, and it's a string form. Let's steal something. Oh, here, there we go. But actually, we want again writer print. The print write all. And it's right. The name of the structure. How do we get the name of the structure? That's an interesting question. Let's have a look. No, that's copying. Oh, maybe here. Module struct. Excellent. Layout. No. Fields. No. Namespace. No. That has to be in the value thing, isn't it? Do we have a type value here? Or is it going to be here? Named int. No. No, 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 no. Oh, nice. Maybe that one. Oh, it's format. So there's no helper for it there. Call convention address space arrow set. Ah, there we go. Do I want it? Is there a name non-alloc? Don't think so, right? To value. Okay, so it's name alloc. So, where were we? Pointer? No, below. Right. ty. We do have an arena here, so we don't have to worry about this stuff, I guess. Okay, let's struct name. And, wow, fancy that. It's actually Sentinel delimited. Do we, okay, can anybody help me here? If I do write all, is it gonna include the Sentinel? Or do I have to add it manually? Don't think so. What? I have to add manually. I know actually Sentinel is part of the data. It's the last element. It's the element at length. So 0. So basically 0 to len minus 1. It's actually at len. Are you sure it's only part of the type? I don't think so. Because if wait, if that was the case, then you could actually just say that it's zero delimited, for example, but it's not in the value. I think it has to be in the value, right? Yeah, okay, in this case, for the array, I don't think it, yeah, you're right. For the array, it's a type. But for a slice, yeah, see, you can access the last one. And it's a 0, so this is the sentinel. And the same thing here, you can actually have a runtime length of 3 and then have the sentinel 0, which is going to be that element. So yeah, so actually, so look, you're right in the sense that it's part of the type for arrays, because I guess arrays are like, you know, statically known, but it's not part for slices, right? Because it's a runtime known thing. So for slices, we need to, I guess, add it manually. Right, okay, yeah, cool. So, but the question is it going to be printed here or not? Wait, what do we get here for name alloc? Okay, we use slice too. Looks it will print it. Okay, sure, yeah. So slice too. Does it takes an iterate searching for the first occurrence event, returning scan slice. Event is not found. The full length. Okay, if the pointer type is sentinel terminated and a match terminated, also sentinel terminated. Okay, okay, yeah. So this should be it, right? This should include the sentinel. Cool. Right, give me a sec. I'm just gonna turn on some lights. Where's my phone? Okay, back. Sorry. Okay, cool. So yeah, okay, because we treat it as a buffer. Okay, nice. So this is gonna make it a lot cleaner. The code, I mean. Okay. So this should be enough. Obviously, there should be a try. And then okay, yeah, it looks like it. Loris, yeah. So print ignores it, and then it's actually not ignored for write whole because just print all the bytes from the buffer. Okay, so we have name. Then we need to iterate over Oh, why do you think so? Why do you think it's Futgani? In the sense that it's not consistent behavior or something? So I can tell you this, that I was working with some interface to C code lately, and I did actually shoot myself in the foot with this one because I thought it's automatically zero terminated, but it wasn't, and I had to add it myself. Yes, I think so. I think right, all prints a null terminated for all string literals. Yeah. Oh. Oh, really? Wait. Yeah, we'll see. Okay. We'll see in a minute. We can actually make it already work. Well, let's see. Wait, so because we're all curious about this, I think I need to delimit like this. Okay, so this is not going to work for our simple example, but we can create a different structure that's empty. Oh no, it will work. We'll just we just won't print any members. So we'll just treat it as an empty structure. I'm not sure if it's not gonna crap itself because of the having a finite byte size but not having any members registered. But we'll see. GDB and DWARF. Okay, so never print it, and then you have to remember to actually print it. Yeah, I mean, it would make it more consistent and right, let's have a look. Let's have a look. Advanced set statement. Wait, abbreviations. Well, the name is foo. Okay. I think it's fine. Yeah, I think it does print the sentinel. I mean, there's not going to be anything inside. Oh, no data fields, but because we didn't add anything, but the name is there. So I guess it does print the sentinel. At least looks like it. Right. Okay. So for that one here, I need to iterate over field values, and I think we've already done this. Because I believe that DWARF requires it to be always null terminated. If it wasn't, unless it's that one, it just so happens that this 0 is treated as a null terminator for the name. Wait, maybe I don't, because it's got children structure, so it has to be 0 terminated at the end to close off the scope. But anyway, DWARF requires it to be null terminated always. So let's leave it as it is. And let's try and print all the fields. I'm not sure if I will need index. And then we'll see if it actually works. I mean, I could also do a test for it, but let's just stick to DWARF for now. Field values. Oh, my favorite. We don't have that. If it's packed, then what? We just exactly. We just close the scope, I think, and return. Implement for part. And or do I need to break? I think I need to break here. Okay. Now, I need this. I need the field values. Hey Lavadut, do I know JS? A little bit. Why? Oh, let's have a look. Ugh. Wait, what was it? Was it control or something? Control shift? Hey, Lotus, help. How, oh, shift control. Wait, shift control. Oh, yeah. Whoops, too many times. Yes. Yeah, but this is print. Oh, you did the right. Okay. Yeah, but this is for the array. What about slice? Let's take the example from here, actually. Hmm. Oh my, what is happening here with this? How did you run it again? Wait, what's up? Same, 5 bytes. Okay. Cool. Oh, Java or JavaScript? Yeah, okay, so you guys are right. So basically, I think it doesn't print by default. If it doesn't, then wait, then this should really be here. That's why it did work. Okay. Yeah, I have tried Visual Studio Code. I actually don't like it. I prefer Vim. How much did it take me to make what code? Like, I'm way more productive in Vim than I'm in Visual Studio Code. Okay, what are we looking for? I want to extract the value from the type. Can I do that? Hmm. Do I need to use this? Right, okay, wait, let's have a quick check at somewhere. Maybe maybe it's already here. We're just not, I'm not unpacking it properly. Ah, value pointer. What's the value? Oh, no, that's not that one. Because that one is, it's got a type. I shouldn't be forced to get the value, right? Because I don't really care. Because I don't really care what the actual instantiation of that type is. I just care about the type itself. So I should be able to somehow extract field names from. Nah. Okay, that's enum. I don't want from enum. I want as a field value. And oh, fields. Ah, excellent. Struct fields. And then we have struct field type. For index. And this will give me fields. That's not an iterator. This is a. Okay, so struct fields. Let's leave that here. Struct. Okay, so we can get, we have struct object, which is perfect, and then we can get fields by virtue of doing struct fields, right? So this will give us all of the fields. We can actually, and we can track the index. Oops. And then we can have field type struct field type at index. Okay, do I need the field type? I feel like I do. I think I need to leave a relocation for it. Right. Okay, so we then do, we need that. So this is the add member. I'll work out the other stuff later. Okay, so we add a nut member, and then we need to add name of the field, right? Probably pre-allocate this, but we can get there in a minute. Name of the field is actually, we're gonna treat it the same way we did above. So actually having a writer, field name. However, I'm gonna extract this in a minute. See how, and then according to you, Loris and Luke, we need to zero the limit manually, which is fine, right? So we've got this. How do I get a field name? So wait, I get all the fields. Can I get it from, I can get it from type, right? No. Because that was, wait, how did I get that name? Oh, name alloc. What's that? Name alloc again? Okay, I think this should be fine like this. So basically, const type me field name. Although I'm sure there has to be a different way, like an easier way. Wait, there was maybe something there. Struct fields payload. What's this? Ah. Module struct fields. Fields type. Okay, so I need to extract the name in a different way. Okay, fine. So const field name field type name alloc. Thank God for the arena here. Although no, it shouldn't be too wasteful. The arena is actually living only as long as the not that function, but the one above in the call stack. So. Although this will change when we have when we properly track relocations. I think we need to do that. Then it will have to live as long as the linker lives. So and then do some garbage collection on it. Okay, and the relocation type stuff. So we have the index. Let's call this field index. So we have index at type form ref4 4 bytes. We create, right, what do we create here? A type. Why did I need this? Oh, because I wanted to create a type. I don't need that. I need for the type, which is field, and then relog index. Okay, so this is where we're gonna stick in the type when we actually know it. Then we have data member location is, wait, do I have to increment by size? Okay, this is in bytes. I need an offset. I need an offset. Not count. No. No offset. Oh, there is the iterator here. Okay, for the offset. Nice. I don't need that one. Struct field offset. And it's as data, so this is also ULIP encoded. Nice. Field offset as no. Field, no, it's the parent type. Pardon me. Struct field offset. It's field index. It's options target. Right, and then we do debug info buffer writer. No, wait. How did I think it was the lab that took it, right? As a type has a hash map with field names. Type has a hash map with field names. Is struct field a hash map? I thought it wasn't. I thought, was that a hash map? Maybe I don't have to actually wait, because that was in define module. What was fields, struct fields. Right, okay, cool, thank you. So actually this is wrong. So what we can do here is wait, yes, okay, so this is actually a this is a field name. We don't actually need this anymore. Sweet, thank you, look. And then we're gonna have field index anyway, but this time do I need, I don't even need this, right? Because I have the type. So potentially, yeah, well, you could, I guess, do do this, get this, and then fields get by key, right? Ugh. Oh my god, can't type. And then have like that. Sharper guy 91. Yeah, the main website. Or I mean, Loris, would you be so nice as to point all the like to print all the links that are relevant, please? Field type. Field offset. Oh, and then I was looking for. Oh, thanks, Luke, as well. Yeah, thank you. Lib. Okay, that one. Yep, and then right? What? Wait. Yeah. Okay, sweet. Okay, so we have the data member location, which is the offset in bytes. Then we have. Okay, this was other member for the anonymous struct, which is fine. Assume. Okay, I think this is it. Let's see if it builds. Yeah, thanks, guys. Thank you, Luke. Thank you, Loris. Oh, for sure, yeah. So I don't know when you joined, but what we're doing here, I'm working on the self-hosted compiler for Zig, specifically x64 backend. However, now we're looking at DWARF, populating the DWARF info for composite types, in this case structures. This is currently in the ELF linker only, so yeah. So now we're gonna have some fun and see if it actually works. So here's the example. Basically what's happening here, this is the notation for defining a new composite type of like a structure. That's what's it called? Structure is a union type, is it? Enum is a product type? Or is it the opposite way? I can never remember. No. Wait, no, that's a product type, right? No. What is a product type? And then union type. No, so that's not it. This has to be. I can never remember the. So yeah, so structure is a product type, I believe. I think. Might be completely wrong. Yeah, product type. I think. Yes? Yes, whatever. Yeah, okay. Union of sum, right, yes. So this is structure as a product type. Yeah, so this a standard thing, is just that notation might be slightly different because we just basically, this means that we create anonymous structure and then assign a name to it, foo. And then it's got 4 members differing, basically unsigned integers of differing width. And then we have 4 accessor functions that take pointer to self as a first argument. So this is basically like, I think it looks very I think anybody who's familiar with Python, this looks kind of similar, right? And I think to Rust as well, because Rust had self. It's just that it wasn't typed. Like it was it? How did you do it in Rust? I cannot remember. Was it like it was function and then first, and I think self, right? Or something. Or was it self? Or mood self, right? In this case, it would be like this, I think. And then that would be, I think, for comparison, I think this is the same in Rust. Yeah, and basically what we're trying to do, we're trying to generate dwarf info for foo with all its members so that we can have a look in GDB as being properly printed. And let's have a look. Okay. Oh, let's try this one first. Oh, check it out. So we have structure type foo. It's 24 bytes. 8, 16. Oh, with padding, right? What's it padded to? 3 times 8, right? Yes, 24. Name foo, sweet. We have so yes, Loris and Luke, you guys are right. It needs a separate. You need to spell out the sentinel yourself, the null byte. I gather from this because this parsed correctly, so that means you know write all does not write the sentinel. So I guess it's in a way it's what you wanted, Loris. It's consistent, and it's what you discovered. Look, that it actually takes len, not len plus. It only covers len like len elements. The furthest index is len -1, which is fine. It's exactly without the sentinel. Anyway, so we have member A, that's the field A. And then check it out. We have add type is located at offset 348, which is here, which is unsigned with name U8. And byte size is 1 byte because it's U8. And then if we keep going, B has its definition, as its like base type at 315, which is that one, which is unsigned 32 with 4 bytes. And then C, 34E, which is often here. Yeah, there we go. U64, 8 bytes, unsigned integer. And then D, again, 315 because it's a U32. So this looks, I think it works. Self. Oh, look at this. Look at this. Oh. I don't know why, but I really like doing this kind of stuff. Yeah. So in a way, Elf is actually with the self-hosted backend, where when it comes to the debug info, we're actually further ahead than LVM. Ooh. Excellent. So oh, and this is the let's do some demonstration then. Oh, no. I don't mean LVM in the way that we're better than LVM. We're not there yet. No. I mean LVM backend in Zig. That LVM backend in Zig, you know, the self-hosted one, it doesn't, we don't have any dwarf info yet. Dwarf 5 versus Dwarf 4 is just you know, a cosmetic difference. There's some new things. I think you can actually express more things. The most important thing for us, what was the website again? Dwarf. The most important thing for us is zig. Check it out. DW lang zig is lang code assigned. However, I don't know when it's gonna appear because Andrew opened that one up. Oh, it was assigned. Oh, on the 14th of March. But I don't know. I don't know if GDB actually follows it. So I don't know if GDB follows it. Well, I'll tell you what, we can actually test it out. What is this? Named struct. Yes. Okay, I'll need to clean it up with some pre-alloc. I'll generate DWARF info for named structs. And while we're here, let's have a look lang. And what value are we assigned? It's not gonna be here, is it? Of course. This is super old. Oh, because this is only for docs, right? Oh, Jesus, so I have no idea how to check for this stuff. Did they resolve it in here? No. Or maybe they're still open. No. So issues. Oh, but this is by number. Shoot. Okay, so it's assigned. Where are they? Ah, okay. So I think, wait. Do we need to wait? Maybe it's here though. No. I think we need, okay, I think this is still an open issue. So it's been assigned, but I don't think it's there yet. Yeah. Yeah, they do. Well, don't you see this? Look. I think it's clear that it's been formatted in Word. Like, this is not LaTeX or anything like that. So. Anyway, okay, so we can do that. Okay. Okay, so we got that done. Anything else that we can do for DWARF here? Let's have a... Oh, okay, let's do some demo then. So yeah, check it out. I'm gonna actually delete this and do... No. I want to do it like this actually. No. And we're gonna actually be opening the debugger here and building incrementally here and changing the code on the left. So Get rid of simple, it's not there, cache. So let's try building it with the what flag. So actually, for those who don't know, what means that we enter incremental updates compiler mode. So that means that we actually do in-place binary patching. So let's do update. Down. So simple, and then let's do first. So that's line 7, and then I don't know. Let's do 4. Line 19, right? And then main is line 24. So we're gonna break out 24 first. Yeah, so everything looks cool. And then continue line first, line 7, which also looks fine. And then line 4, which is line 19. Yeah, so everything is cool. So let's quit the debugger, and then let's move main here. Okay, and then why not? We can actually reshuffle them a little bit, because who cares? So the body of none of the functions actually was changed. So we don't actually touch the machine code here. We're gonna update it. Break and simple, and then look, main is line 1. First is line 2 locations. We have 2 locations. That's interesting. Maybe that's not maybe this is not working then. No, for okay, so something was not updated properly. So then simple line 1, line 23 is for first. Okay, it's still okay though. But we have 2 locations, so I guess we don't garbage collect the old stuff for some reason, but I'll need to investigate. But so far so good. And then we have fourth, line 19. And then that's it. So okay, so actually the line number is fine. It's correct. It's been correctly updated. I think there's some garbage left in the DWARF info somewhere. Let's have a look. I need that. Can exit. Yeah, I just realized this is going to be quite difficult for me because this is all encoded in a way that I won't be able to find it properly. But anyway, yeah, see? So it works. It's actually pretty freaking awesome. And the best thing for me is that or for anybody who's working on the x64 backend, or actually anything that is using ELF for that matter, now is gonna have a much nicer experience because you can do next. You can step in, return print self A, and everything is there. It's like, oh, it's just so good. I feel fulfilled. And then, oh, this is really nice. I could actually play like this all day. So the debugging stuff is gonna be so much easier soon, not having to look at this all the time. Oh, magic. It's not that I'm not saying this is not useful, but still. Okie doke. Right. Sweet. So we have the struct type done. Maybe let's clean up a bit. Does it actually make sense to pre-allocate here? I think for the first one, no. For this, I don't think so either, because we use ULab anyway. That's fine. Probably for that one. Ensure unused capacity is going to be struct +1, right? And then we can have we don't actually need it to do it this way. And then append slice. Wait, what does anybody knows what append slice does? I don't think it takes. It also doesn't append the sentinel, right? I guess because it only gets up to len -1 and then quits. I'm guessing. Okay, do it this way. Perfect. That's a check that we need to leave in here. We don't need that actually. We can get rid of it because we've got all the info required. Yeah, well, okay, yeah, cool. Yeah, so it won't include the sentinel. So in general, remember to, yeah. So the trick here, the most important bit about this, if anybody works with dwarf, especially the abbreviation, like for creating the dwarf info for type, the composite types that have children, you've got to include the sentinel at the end. If there are children. So if you basically open the scope by having add member for struct, that means that yeah, we got children. So we need to close the scope because otherwise dwarf interpreter will not know when to stop. And here we can also do some fancy pre-allocs. Ensure it's gonna be what field name len +2. Right, and then oh, that one debug info buffer append. Oh, by the way, I really need to add some dwarf tests and linker tests, like compare output linker tests. I actually have some stuff in my local branch. I need to basically extend stage 2 tests so that we have more coverage because now that I'm gonna start working on ELF, I am bound to make some regressions in Mako too. Resize, Relux, ULab, and then append 0 here because that's fine. Okay, cool. You're finally rebuilding video editing setup. What do you mean? What happened to it then? Oh, the interview actually about Rock, that was in Seattle, right? But what happened to your video editing setup? Oh, really? You changed the PC? Wait, you had this beefy gaming machine. Like I can't remember the make, but you said it was like some kind of a hipstery, super powerful PCs or something, wasn't it? Yeah, we miss you too. Look, it was fun. Although Seattle per se, I'm not a big fan. Ah, right. What was the make again of the new PC you have, Loris? Append zoom. Yeah, exactly. Meet up at a warm weather location. Does it sound like Milan maybe? Funless, yeah, Monster Labo, cool. I need to check it out again. So if we want to meet at a warm weather location, so Amsterdam is out. Like no offense, look, but the weather is pretty similar to Seattle. And then Warsaw is out because it's pretty cold right now and it's snowing again. But Milan sounds great. I love Italy. Good food, good wine. What else can you want, right? What else do you want? Like, do you need, in fact? And good coffee. And pizza, exactly. And pizza. Thank you, CryptoCode. Let's try this again. Sweet. Oh my god, instead of dicks every day, yeah. For those of you who don't know, Dick's is like a local burger joint in Seattle. Because that sounds weird, look. It should be generate DWARF and debug info for named structs. And you did it. Look, you did it. You started it. Okay, what else could we do here? So we've got debug info for structs. Maybe we could keep it. We're just gonna have. Maybe it's gonna be fun having it around or something. Yeah, let's do that. Let's keep this stuff. Betraying your company. Okay, let's have a look. What else? There's some other cool things that are missing, I think. Hey, can we actually pass it by kind of like by value, I guess, in a way, but it's not really because it's gonna be a const pointer. I think it should be. We don't have it yet. Oh, see, look what you. Oh my god, what did you do, man? So this is implement const of type. No, I'm just kidding. Okay, why do we? Okay, this is the thing that I think Andrew was pointing out that we have this stuff here. Oh, gen type value, right? Okay, we should probably move all of this stuff into common code gen code path, right? I mean, you probably will have ideas about this because you have similar thing in WASM, but I think it should really be in code gen with everything else. Yeah, so for the structure, I think we need to, according to this, I think for the structure, we need to basically be able to say, yeah, this is a different, well, it's different because of the MC values, right? Yeah, the generate symbol function is the same for all. Yeah. But I think some of this stuff actually, I think we could actually make it into a nice interface, to be honest. And then within the interface, we can actually switch. Because, for example, immediate is not going to change between ARM x64, x86, and so on. It's only, I think it's even going to be the same for WASM, is the register stuff that will, right? So we could probably have like an interface like we have here. Like, functions like open path, create empty that we have switch. And then, or we have if, else, if, else, if, else, if, else, if, else for different architectures. And then if it's WASM, then obviously there is no register, so we just put it into whatever abstraction you have. For everything else, it's a register. If it's a stack offset, then it's probably common for both, for all, sorry, something like that. Okay, so to have a wait, so a pointer would be fine. So do you have actually did you add support for structures? Constructors, wait. Oh, did you? Oh no, no, but you mean for the this is for generate symbol. No, no, I don't mean this. I don't mean lowering the bytes. I mean like generating MC value for a construct. Because I want to add it here. The only thing I'm not clear about is why are pointers like Oh, okay, that's what you do. So, okay. So, is that would it be required for structures though? Because I'm wondering like so this is complaining about this being so foo here. But actually this value because it's a con is because it kind of okay, right, okay, gotcha, okay, because so the way we actually do this, we lower this into bytes. So that goes into arrow data, right? And then and then okay, it goes so we need to basically have a pointer to memory. Yes, okay, makes sense. Cool. What? Yeah, yeah. Anonymous local symbol for it. Yeah, I don't. Should it be anonymous though? Let's do a quick example, a quick investigation then, if it should be anonymous. We're gonna use state one. What? Why? What? It's not a decal. Why not? I think it should be a decal. Oh, it's probably unnamed here as well. Is that what you mean? Because I don't think it's gonna be in the symbol table here. Oh, that is a lot of junk. Oh, there's foo first, which is a function. Oh, so this is just a scoping thing. Okay. Mm-hmm. Mm-hmm. Yeah, so this would work, right? This would actually, I think, generated still nothing. Oh, there we go. This one is now named because it's in global scope. So now it's a decal, you're saying. Mm. But now it's a named now it's a decal that's named, and in the other case it's not a decal, still named, or even can be unnamed or whatever, but it belongs to a decal that's a function. Yeah. So can you like recap this then? Are we meant to, is our backend meant to do it, or is it gonna be, or is Andrew gonna hook it up somehow to the front end or something? Okay, so the backend, so basically it's meant to be done as you do it. Effectively just right. Just cleaning up the mechanism of like having a decal or not a decal. Okay, so from my perspective, I guess, because we have what? We have for that stuff with an elf, we've got two entry points, right? We have elf has a specific section for this. The section is called arrow data. No, the text section is for executable machine code. In general, the problem in storing anything in the text section like data, and there is a thing in Mako called data and code sections. Sorry, data and code subsections within the text. It's okay. I mean, you can use it. It's for basically co-locating your executable machine code with the data that you have to pull in, so that you don't have to actually jump via GOT or far away to actually get the data out. But the thing is, though, when you lower this into bytes, you need the pointer. When you need a pointer, you need to align it properly. If I leave this in text, I potentially increase the alignment. So I can have very minimal code, executable machine code that's aligned to, I don't know, like 1 byte for x86, for example, 64, I mean. So 1 byte, and then I stick in, I lower foo into text, into executable machine code, and suddenly my alignment is 8. So then every atom has to be aligned to 8 at the 8-byte boundary. Or maybe it doesn't have to be per se. No, I don't think it has to be. It has to have its own alignment, which is fine. But then the section size is going to increase, right? Because we have an atom that's actually 8-byte aligned, so the entire section has to be padded out in it a little bit so that the alignment is, the maximum alignment is met. In this case, 8. That's why we have the arrow data, so that we can have a section of only this stuff. Because this is the output from stage 1, so this is what LVM is generating, and I don't see anything. To be honest, I don't see anything fancy here, because we have what? We have read-only data. Like this is the page 0 stuff, or the header, like a sentinel crap. Yeah, definitely you should. So we have this 0 section, which is fine. We can leave it, ignore it. It's a null section, right? We have the read-only data. That's allocate, merge. string. I think S was for strings, yeah. Then we have executable machine code, which is allocate and execute. Then we have thread zero fill. T is for thread, I think, right? Yeah, thread local storage. We've got got, which is write and allocate. We have zero fill, which is write and allocate. Yeah, sure. And then we have the debug stuff. Comment, that's with the information about who linked, who compiled, and all this stuff. Then we have the symbol table. Then we have the section header string table. So that this is a separate string table that allows you to pull in the information about the section names. And then we have the string table. So there is no fancy section for this. It's just read only data. That's where we should put it. That's where I'm going to put it in ELF. The question though is, so basically we have two-way, we've got this allocate decl indices which we will not use. Then we have update decl somewhere. Right, update decl, right? And update func. Func is for executable machine code. But update decl is for, as you said, it's for stuff that's being created by the front end. So I guess I don't know, I might add like update anonymous decl or something, or just lower it or something like a separate hook here or something like this. Yeah, I think that's perfect. To be honest, I think this is the solution. ELF is like, for example, ELF is much simpler in this aspect than Macro. In Macro, I think that stuff would go. Oh no, it will still go into data const. It's called the segment const. So it's like arrow data. Because in Macro, you can have a separate text const, which is not executable machine code, but it's with the same segment as executable machine code, but it's got like different constants. Like, for example, constant for poison, like 0x AA in hex, right? Or something. Okay, cool. I'll definitely want to look into this too. Right, okay. And what about behavior tests? So what are we missing still? Basic.zig. Oh, I didn't have a look into here in a while. Let's have a look, ladies and gentlemen. Oh, I think we have a. Yeah. I know it does. I said like I was trying to escape stuff within the basic. The Zig basic, for different backends. I gave up. I was like, there's so much stuff. Oh, interesting. We have a problem in, again, this is air call. Hey, wait, maybe it's gonna be a simpler one first. Because I know the basic is pretty big. What about the 6 to 4? Yeah, oh, see, now that's better. But what is it though? Oh, but this requires lowering structures into const. I think. Doesn't it? Yeah. So I think this is definitely something that I need to look at next. I think there's more stuff also missing in different bits here. Like even. Oh, this might work now. Nope. Oh, if you have a top level field like this, it's also loading a struct. Jesus, everything. Oh yeah, okay. I definitely need to add this stuff in then. Unbelievable. What about that one? That one as well? Or maybe not. Oh, F32. No. Yeah, floats? Later. I don't even want to tap them. Let's stick to the nice okay, so this is again, I think, yeah, struct, lowering struct as a const, right? Okay. Yeah, see, most of this stuff, I think if I add this stuff to the linker, because it's mainly a linker thing. If I add it to the linker, I think ARM and X8, X64 and potentially ARM64 will get a big boost in behavior test passing. Yeah, this one as well. Yeah, because mostly, see, most of this is construct, which I'll need just basically just add. Maybe after today's meeting, I can have a look. Yeah, because that one, I guess, as well. I don't expect that one to. Oh, okay. Union const type user. Arrays. Yeah. Sure. Absolutely. Okay, so that one was struck. What about type? Because Andrew was also telling me that wait, did he escape anything here? He did find some kind of a problem with elf. Can't remember for the life of me what it was, but it was basically, I think we were crushing at some point. If there were, like, if there were too many tests for elf, I think something was not being extended or something. I need to have a look. I can't remember how to repro it though. Yeah, what about null? There's something. I wonder if actually null works. You probably also need some lower, maybe not, because they should be for the simple types. I guess this should work. Hmm. Yeah, so this is probably something I'm gonna have a look. Wait, built-in. If built-in is a backend. You know, I'm not looking forward to actually adding those again for ARM64, and that's gonna happen soon. Oops. Okay. Didn't break anything. So this works. What about on ARM as well? I think chemo ARM. Cool. Okay, this one doesn't. What about ARM? Nope. Oh wait, is that? non. Ah, so this is my favorite function. Gen type value. Okay, so can leave. No, no, no. I think that one is going to be the same. Oh no. Ah, hey, sweet. Oh, did I not save it? No. Okay. Oh, that stays as well. That's comp time, isn't it? Yeah. And this one lowering cons. Oh, oh, this is also comp time. This as well. Cool. Uh-oh. What? Wait. What? What? Why? What? Where? Okay, this is bizarre. Hmm. This is worrying. How the hell does this work then? Wait, does it correct to something else? No. What the hell? Oh, right. That's why. Actually, is it? I don't think it is. Because it's being corrected to bool. Wait, that one is, right? But that one, if I do this, then both should pass. Okay, this beats me. Like, what the hell? Not that one. Codegen arm. Wait, this is weird. No, it's the same thing. What the fuck? Is that because I'm using target? No. What the frap? Okay, anybody can explain this to me? I don't like magic. Magic means that something is seriously broken. Yeah, so that one works because it's a bull. It's fine. Well, that's what I thought. And yet suddenly for arm, it is Y. Wait, does it even work? It works. It is magic. Yeah, and then I do... Oh, because I didn't enable it. Okay, I'm shocked. I have no idea what's going on. Okay, see now it... Okay, this is picking it up because it's I32, so it's 4 bytes and we don't have a coverage for this, right? The other line, which one is the other one? You mean right now? Yeah, but it's still... I don't understand this, to be honest. It is weird. And here as well, look, I'll get rid of this one. And obviously we're skipping it and it works. But then if I unblock this one, or even... Sorry, arm. Maybe this is something I should bring up today. I don't know. Bizarre. Even that one works. The hell? It's weird, right? But I did cross-compile to x86 Linux. See? Because I thought so too, but it works. Oh, and now ARM works too. Oh, because I... Okay. My bad. Sorry. Okay. So this one should trap. And it traps. And then if I do this, then it's fine. And then... And... Okay, because this is unwrapping nothing. Unwrapping is implemented. Okay, that's... Okay, I believe this. Yeah, fine. And this one needs what? Okay, optional pointer to 0-bit type. See, so that one is fine. It's working correctly. So this is okay now. And so is that one. Okay, cool. I don't know what that is. This is wait, we create a particle, so some kind of a structure. This one probably will complain. Yeah, okay. This one is missing const. Yeah. What? Oh, okay. In this case, actually crapping at a different place. But far. That's not at runtime. Oh, wait, look. Implement non-pointer optionals. Maybe this is where it's crapping itself. Implement non... Yeah, it's here. Oh, okay. Right, okay. Oh, Jesus, I got scared. Magic is not good. It's just that the error names are very close, right? So it's very easy to make a mistake here. Mm. Okay. Oof. I still might ask. This is So wait, so we have why do we only check for ABI size 1? Can we not just check for anything that's up to ABI size 8? Oh, you mean already here, and that will not go there. Yeah. Yeah, because we have has runtime bits is in a few places. Mm-hmm. But yeah, makes sense. What is even mm-hmm. Yeah, I think I'm gonna quit as well right now because I'm kind of hungry too, and I've been going at it for what 3.5 hours, but it's been a good session. I hope you guys enjoyed Dwarf. Hopefully, I'll be able to do some more next week, maybe. See, maybe arrays, but I think I'll need to lower arrays first to bytes to be able to have some. Thank you, look, to have some thing to play with. But yeah. Anyway, let's see who can we raid. Any suggestions? Oh, Lorison, thank you for the noise filter. That's very helpful. Hmm. Who can we raid? I don't know. Don't know. Is Raphael doing anything right now? No. Don't see him anyway. So maybe how about some coding a spline video in Unity? This looks interesting. I don't know if people are interested in the graphics programming, but it looks cool. Maybe some compilation speed. Let's see, what is this?